My Capstone project is a programming language, and you all must have heard of its name. It is the MSD script. So the project is extended on our course project. And because I'm really not a fan of C++, I've been using a new language, Racket, which is a language that Matthew has worked on for decades. And the purpose of the project is, of course, not to publish a new language, but to better understand existing languages by learning relevant concepts and implementing those concepts. And also, I guess most of the cohort are doing web apps or Android apps, and I thought it would be really cool to do something different. So before we start, let me give you a quick review of what we did in that course. What we did is we implemented a programming language by building a parser and an interpreter. The parser takes the user input, which is a string, and parses it into an expression based on order of operation. And then the interpreter interprets the expression and gives the value back. So what's new about my Capstone project? Well, first of all, I've introduced the class syntax. And here's an example. A class consists of a class name, the name of its parent class, a list of member variables, and a list of methods. And now the input is treated as a program, which consists of class declarations and an expression. You can think of the expression as the main function. It's what the user wants to evaluate and get a result back. I've also added a compiler layer, and the structure of the program looks like this. The parser parses the input into something called program I, which is a pre-compiled program. Then it goes through the compiler, which compiles the program, and then through the interpreter, which interprets the compiled program and returns a value. And that raises the question, what does the compiler do? Well, basically, the compiler translates human understandable code into interpreter understandable code. And of course, we could leave the translation to the interpreter, but by adding a new layer, the translation process can be done just once, which reduces repeated work and makes the interpreter go faster. The second new feature is related to the notion of side effects. An expression is said to have side effects if it changes or modifies something besides computing a value. So for example, 1 plus 2 plus 3 has no side effects. It just evaluates and returns 6. It doesn't change or modify anything else. But the print function has side effects because it prints something in the console. It changes the state of the console. And also, a variable assignment has side effects because it modifies the environment, and the statements after this assignment could use this variable. And side effects matter because it makes the notion of loops and sequencing useful. So for example, if you put an expression with no side effects in a loop, it just gets computed over and over again and doesn't produce useful results. And it's the same case for sequencing. These expressions are evaluated, but the results are discarded, and you might as well delete this block of code. So in order to implement loops and sequencing, I've added built-in functions like print and print line. They're also useful when a user wants to debug their program. And the second is mutable state, which includes mutable variables and mutable objects. And mutable means something can be changed. So mutable variable means a name can be bound to a new value. And the mutable object means the field of an object can be changed. And now that we have things with side effects, it's time to implement the notion of sequencing and loops. The sequencing uses semicolons to separate expressions, and the input is treated as a list of expressions, and each of which gets evaluated in order. There's the for loop, which loops over all the integers between the starting number and the ending number. There's the for each loop, which loops over a list. And the third new feature is recursive variable binding. In our previous MSD script, when we want to make a recursive function call, we have to do this nasty stuff. And the problem is that every time we make a function call, we allocate a closure, which has time cost and space cost associated. And in this case, every time we recurse, it makes two function calls. And by using the recursive verbal binding, we reduce the number of closures needed, and thus making recursive function calls run faster, and also the grammar looks a lot nicer. So given all these new features, I've put together a big application. We define a student class with a name and a getName method. The MSD student inherits from the student class and it has GPAs for several courses and a getGPA method. We create a bunch of student objects, put them in the list, and use the for each loop to loop over the list and print out their names and overall GPAs. And here's the conclusion. Overall, the switch to Racket is a great choice. Racket is less error prone than C++, and its error messages are much more neat and useful. But of course, high level languages means less control over the project. So there's a trade-off between your happiness and the program's efficiency. But overall, I'm pretty glad that I chose Racket and Matthew as my advisor. The experience is like drinking beers with the man who invented the beers. It's awesome. And yeah, thanks.